All right, so this lesson is a review on factoring using MA and grouping. So MA and grouping is used when you have a trinomial. So that means we have a trinomial, and that's three terms. So we can use this with three terms. We can also use it sometimes. Actually, you could use it with two terms, special two terms, otherwise known as binomials. We can do that as well, but most of the time it will be used for trinomials, three terms. Okay, so what I wanted to point out to you was just kind of reviewing a little bit about foiling. I'm not going to do the foiling because that's a whole other lesson, and I would assume, I shouldn't assume, but you're in Algebra 2 now, that you should know pretty much how to FOIL. All right, so let's just talk about foiling though. I tend not to use FOIL only because I forget which one's the O and which one's the I and all that. I just never was taught that way, so it's harder for me to remember to do it that way. But all you have to do again is if you're doing FOIL, if you notice when you do FOIL and you spell the FOIL, well, how many letters is that? It's four letters, right? So if you notice, if I do follow FOIL, which is first, outers, inners, last, there's the first, there's the outers, there's the inners, and there's the last. Okay, so if I were to do all four of those, I would generate these four terms. Now, I didn't clean them up, and there's a reason, because I'm not really, my point of showing you this is not to do a FOIL problem. It's just to show you what I'm generating. And if you notice, when I do FOIL, I generate four different terms. Yes, I can combine them, and that's why when I combine them, I get three terms. But right now I have four terms. All right, what did you just learn how to factor using four terms? You used grouping. So we can actually use grouping to solve all these problems. Okay, but I also want you to notice too is the fours, or the numbers in here, the 4 and the 5, is being the 4, the 5, and the 4 here, they're being used as kind of a multiplier of x. So basically we're using the 5 and the 4 three different times. We're using it for the outers, the inners, and the last. And if you notice that x gets multiplied by 4 here, x gets multiplied by 5 here, and 4 and 5 get multiplied here. So when you combine terms here, what are you going to do? Well, I'm going to add them. All right, so the whole premise about MA, which is short for what multiplies to give you the last and adds to give you the middle, that's where that comes from. So you're just going to look at what numbers give you 20, to add to give you the middle term, which in this case, if you do the math, it would be 9x. Okay, so factors of 20 that give you 9x are 5 and 4. And those are the only two numbers in existence that will give you 9 when they're factors of 20, things that multiply to give you 20. Like 10 and 2, that multiplies to give you 20, but adds to give you 12. 1 and 20 multiplies to give you 20, adds to give you 21. So there's only 4 and 5 are the only two in existence that will multiply to give you 20 and add to give you 9. So there's only a certain combination, and we're going to work through some of these. But I have a couple of examples here, and I'm not going to go through the rest of them, but I just want you to be able to see that same thing. -2 and +7 will add to give you your middle term, but then multiply to give you this last one, and that's the pattern. Okay, so what I wanted to point to you is, is this last one. This last one's a little bit more complicated because it's got a multiplier on the x. It could have it on both x's, but in this case I only have it on one x. So that affects your what's called your leading coefficient, or the number that starts it all off. All right, so basically what happens, what do I do? What am I going to do when I solve one of these problems? Well, if you notice, -6 plus 1 give you -5, but -6 times 1 doesn't give you -3. It gives you -6. So what we're going to do is when we go to do this MA stuff, is we're going to multiply these two before we start off, and to help us work this out. So our goal here is to get a problem that was a trinomial, a 3-term, change it to a 4-term polynomial, and then work backwards to get it looking like a FOIL problem. That's our goal. All right, so let's start. Okay, so here's the first one. Factor x squared plus 9x plus 20. All right, so again, we've already talked about this one, and it's okay. That's fine. So we're looking for things. Now, first thing you should do is you should always look to see if you have a leading coefficient. In this case, it's a 1. So if I were to multiply 1 times 20, I'm still going to have 20. But you should get into the act of multiplying the first and the last term to get your factors that you're going to be looking for, the number of the factors you're going to be looking for. So in this case, 1 times 20 gives you 20. So I'm looking for factors of 20 that give me 9. And we already know this because I've already kind of talked about it on the last slide. But if it multiplies to give you 20 and adds to give you, I can't get that written in there, but that's okay. There's a 20 right there anyway. Okay, so there's a 20 and then adds to give you 9. So we already know that 5 and 4 multiply to give you 20 and add to give you 9. So those are the two factors. So what we're going to do is on the next step, once you find out those magic numbers, is to put them in for, oops, yeah, I don't want to do that. Put them in for the numbers, the 9. We're going to substitute in 2 terms. And why are we doing that? Because I kind of messed that up a little bit. Hold on a second. All right, just have to fix that a little bit. Okay, so the 5 and the 4 in there, and now we're going to go by grouping. And again, if you have some question, again, on a little bit more in depth on grouping, go back and look at my video on factoring by grouping. But we're going to take the first 2 terms and take out their GCF. So in this particular case, x is our GCF, so we're going to take the x out. And again, when we take an x out of both those terms, we're left with x plus 5. Now again, what I taught in the last lesson is whatever you've written in parentheses, write it again, and then try to figure out what needs to go in here so that I get generate these last 2 terms. Well, it looks like if I need a 4x and I have an x, I need this to be a 4. And now I'm going to double check. 4 times 5 does give me 20. So that's the right combo. And again, take the numbers that are on the outside, here and here, put them together in their own parenthesis, and then copy what they had in common. All right, and that is factored. Okay. Okay, so here's the next one. This is one that we didn't go over, so it's a little bit harder. All right, so now I have x squared plus 5x minus 14. Again, I look at the first term, I multiply those two, still going to give me negative 14. Okay, so if I do my MA, this is negative 14, and then adding to give me 5. All right, so now I'm going to try to think of things that give me 14. Now, because I have a negative 14, my signs have to be different. Okay, so 14, so I have 14 and 1. Well, 14 and 1 are way off from each other, so they're not close to each other. So you have to get a 5. So they have to be somewhat close to each other. So another one I can think of is 7 and 2. So let me put negative 7 and positive 2. Well, those multiply to give me negative 14, but when I add them, I get negative 5 plus 2, negative 5. So it's almost right, but it's not completely right. It's the right number, but the wrong sign. So which means all I have to do is swap these two so that the negative's on the 2 instead of on the 7. And then when I add them up, I'll get a positive 5, which is what I wanted. Okay, so then let me change color because I'm kind of bored of red. I'm going to take my polynomial, my trinomial that I have written down here, and I'm going to copy it, the first term and the last term. And then I'm going to insert the two numbers 7 and negative 2 as 2 terms. So 7 and negative 2. All right, then I'm going to do grouping again. So I'm going to say, what do I have in common? So it looks like I have a x in common, which most of these, it's going to come, you'll get into a rhythm that this is going to be a fairly easy thing to do. All right, if I take an x out of both of those, I'm left with an x plus 7. So I'm going to copy my x plus 7 over here. And now I'm trying to figure out what do I need to get in order to get negative 2 and negative 14. Well, it looks like in order to get negative 2x, and I have an x, I must put a negative 2 in here. And then I'm going to double check, does negative 2 times 7 give me negative 14? And it does. So that's cool. So again, I'm going to take the outside numbers, put them together in their own parenthesis, and then copy what they had in common. And I'm done. Okay, so let's factor this one. Okay, so again, we're going to take the first term, which is a 1, multiply it by 27. And I know that kind of feels kind of stupid at some point, but you got to train yourself to do the multiplying of the first and last term, because you are going to be an instance, and we're going to do a couple in a minute, where you need that leading coefficient and you're going to be using it. So you might as well get used to multiplying the beginning and the end and getting used to it. All right, so MA. So I need to multiply to give me 27, and I need to add to give me negative 12. That's what I need. Okay, so what are things that give me 27? Well, 27 doesn't really have a lot. It has 1 and 27. It has 3 and 9. And that's it. So those are the only ones we have. And 1 and 27, again, even if we're to add or subtract or do whatever I need to do, 1 and 27 are way far apart. So they're not 12, they're not even close. 12 is not even close to 1 and 27. So we don't even want to consider 1 and 27. So as you're testing, you kind of want to think about that. Does it make sense for me to test something that are so far apart if the number's not that big? All right, so negative 12, so I'm going to do 9 and 3. Now, I'm going to do 9 and 3. If I do 9 plus 3, I get 12. All right, I'm supposed to get negative 12. So that tells me my signs are wrong. And again, in order for me to get a positive 27, signs must always be the same. I must either be both positives or both negatives. So negative 9 plus negative 3 does give us negative 12. So check, that's the one I want to use. All right, so I'm going to take my polynomial, my trinomial, rewrite it. I'm going to throw in my new and improved numbers here. So let me throw in the negative 9x and negative 3x in there. Okay, so now again, I'm going to look at the first two terms, take out what they have in common, which is an x, write what's left over, which is, let's see, x minus 9. Copy x minus 9 again, and then ask myself, how would I generate these last two terms with what I have? So if I have to get a negative 3x and I already have an x, then in here must be a negative 3. Now double check, does negative 3 times negative 9 give me 27? And yes, it does. So we're good. Okay, so we take our first, the things outside, each side of the parentheses, write them in their own group, in their own set of parentheses, and then copy what they had in common. And you're done. Okay, so here we go. So we got a problem where we now have a leading coefficient of 2. So when we do our multiplication now, this is going to give us negative 2 times negative 3 gives us negative 6. So now we're looking for things that multiply to give you negative 6, but add to give you negative 5. So that's what we're working on. Okay, so negative 6, remember, signs need to be different. So as we're thinking of things, now the tricky part is you're tempted to put 2 and 3, because 2 times 3 is 6. But since the signs have to be different because it's negative, you don't want to use 2 and 3, because if I make both of them, if I make one of each, I'm never going to get to negative 5. All right, so I'm going to use negative 6 and positive 1. There it is, negative 6 plus positive 1 gives us negative 5. So that's the ones we want to use. So rewriting 2x, so I write the first and last term because I'm not doing anything with it, and then I'm copying my two numbers in, negative 6 and positive 1, and I'm just, again, you can put just plus x, but I know a lot of visual learners like to see that 1 there to help them out a little bit, make sure they got it. Okay, so, oops, missing a squared there. Okay, so what do the first two terms have in common? They have a 2x in common this time, not just an x, but a 2x, because they have, you can divide 2 by 2 and you can divide 6 by 2. So I'm taking out a 2, and then I'm putting my parenthesis, and now I gotta get 2x squared, so that's just going to be an x. My 6x has a 2x, but it needs to be 6, so I need to multiply it by negative 3. Copy it. Now, we've got to figure out what we're going to put in there. If I put a 0 in here, and this is all a multiplication, if I put a 0 in here, it wipes everything out. So be careful. Don't put a 0 in there, because if you put a 0 in there, then remember, this whole ugly thing is a multiplication. And if you put a 0 in here plus 0, then you're knocking off the last two terms. So don't put 0 in there. You got to put something in there, because if you don't, then what happens is, if you don't put something in here, you leave the 2x, all you'll generate is the first two terms. So all you get is the first two. You'll never get the last two. So you need something in there. Well, since I have an x here and I need a 1x, all I'm going to do is put in a plus 1. Now you can actually see it looks like it says plus 1x, and then this is going to give me negative 3. So that's the correct number. So again, outsides, put them together, copy what they have in common, and you're done. All right, one more. Okay, so this one we're going to, actually we have two more. Do the same thing. I made the numbers a little bit higher. So multiply those two. We're looking for negative 42. So we need negative 42. That's a pretty high number, right? And add to give you 1. Okay, so negative 42. We're looking for factors of negative 42. Now, that's not so easy for a lot of kids, because 42 is a pretty big number. They know their times tables pretty well, but you get down to you get into 42, and it's, oh, I don't even know what to do. So what do? So you start saying, well, what can I do? Well, the deal is here, remember, they're only off by 1. So the two numbers you're looking for are only off by one number. And because it's negative, that means I have one of each sign. So since I have a positive one, my two numbers I come up with, the bigger number needs to be a positive. So if you think about things that give me negative 42. So let's just pick an easy one. 2 and 21. That was easy because I just said, well, if it's an even number, I'll divide it by 2. So I'm going to make the bigger number positive, like I said. If I add these two together, I no way get close to 1. This is 19. Okay, so that's not the numbers. Okay, so what else can I do? So let's think about this. And if you're really horrible at this, grab a times table. 12 by 12. You know the way you guys learned your times tables. You had a big, huge chart of numbers, and that way it has all the factors, and you could just hunt down the 42 somewhere and find your factors. All right, so when you do that, I will find that negative 6 and 7 are my two numbers. Negative 6 times 7 is 42, but again, I got to get a positive one, so when I add those together, I will get a positive 1. All right, so these are the numbers I want to use. So here I go. So 2x minus, squared, 6x plus 7x minus 21. All right, so I've rewritten the two terms that I had written down here from 1 into 2. And then I'm going to, again, take the GCF out of the first two terms, which again is 2x. I need 2x squared, so I write x minus, I need a 6x, and I got a 2x, so I'm going to multiply by 3. Again, these guys should generate these two. All right, copy. And again, I need a positive 7x. I have an x, so I'm going to put a plus 7 in here. again, double check to make sure that that gives you negative 21, and it does. So now all the numbers that are written on the outside, put them in their own group, and copy what's left. Again, don't write two of them because that's not the distributive property. So go back and look at the distributive property in my grouping videos if you need help with that again. And that's your final answer. All right, so this one is going to be a little bit fun, and you'll find out why in a second. All right, so again, first thing to do when we tackle this is to do what? Okay, we're going to multiply 4 times 5, and that's going to give me 20. Okay, so far nothing, everything's cool, it's the same. Okay, so it multiplies to give you 20 and adds to give you 12. Okay, so think about what are things that multiply to give you 20 and add to give you 12. So I know right off the top of my head I'm going to put 5 and 4. Okay, if I put 5 times 4, that is 20, but 5 plus 4 gives you 9. Nope, no cigar. We need to have a 12. Okay, what else gives you 20? 1 and 20. Okay, 1 plus 20. Again, I wouldn't have really realistically tested that one because they're too far apart. I mean, it's too big a number. I'm looking for 12. So I got, how about, let's see, 10 and 2. Okay, 10 plus 2 is 12. Ding, 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 ding. All right, so those are the numbers I want to use, 10 and 2. So I'm going to rewrite 4x squared plus 10x plus 2x plus 5. All right, so what can I take out of 4x squared and 10x? That's my first question. What is my GCF? My GCF of 4x squared and 10x. What can I take out of both of those? I can take out a 2x. All right, so if I take out a 2x, what am I still left with? I'm left with a 2x plus, I got a 10x, I got a 2x, so this has to be a 5. All right, copy it. All right, now, we talked about this before. What do I put in between here? I didn't leave myself much room. I already have my 2x plus 5 to match what I got down here, but I can't leave this blank. What do I put? Right, I'm going to put in a 1. Okay, so I'm going to write down what I have on the outsides together and copy what they had in common. And that's my answer.